I'm Jonathan Pizzino, Principal and Owner of Scientific Web Services LLC, and this is a brief video about how to use SWS Geothermal Platform to run GeoPhires and Monte Carlo simulations. Here we are on SWS Geothermal Platform in our browser, and let's say that we're interested in looking at a super hot rock example. Here I've selected super hot rock example 1, and I can go ahead and press run. Here we see we've got the parameters for our example populated in the left column, and in the right column we've got our case report or results that GeoPhires generates for these parameters. We can see that we have an average net electricity production of 30.81 megawatts and an electricity break-even price or LCOE of 5.86 cents per kilowatt hour. Let's say that we want to look at this example with a gradient that's similar to Fervo Cape Station's geothermal gradient, which is 74 degrees Celsius per kilometer. So we can go to our parameters and we can edit the gradient 1 parameter from 50, which is the default value for this example, to 74. So we enter that and then we just press run GeoPhires and we get an updated version of our case report. So we can see this has actually significantly increased our production to over 60 megawatts and significantly decreased our electricity break-even price or LCOE to 4.11 cents per kilowatt hour. And that's expected because a higher gradient means higher production temperatures, higher enthalpy, more production, and cheaper electricity, of course. Let's say that we also want to model an investment tax credit for this example. We can do that using the parameters editor. So we click the editor tab, and here we see our currently input parameters. And we can also scroll down to the parameters browser, and we can type in investment. We find our investment tax credit rate parameter, and we will enter a value of 0.3 for 30%, which is the current investment tax credit rate. We can see that reflected here in our input parameters, and we can even add a comment indicating that this is the current ITC of 30%. Great. So then we can now rerun with our new input parameters with the investment tax credit rate, and we can see that our LCOE has fallen more than another cent to 3.1 cents per kilowatt hour. And that's expected because we can see under our capital costs that we get a investment tax credit of $95.2 million. Great. So we can also save this result for later reference or use, and that will appear under the Saved Results tab here. And we can edit the description to say plus Fervo Cape Station gradient plus current ITC, and we have that example saved. Okay, let's say that we also are interested in looking at this example with a flow rate per production well that's more similar to Fervo Cape Station, which for reference is a peak of up to 120 kilograms per second. Here in this example, we've currently got 55. So as we did before, we could go and enter our production flow rate per well to a value that's closer to that, let's say 90, and of course go run GeoPhires again, and unsurprisingly we get an even higher average net electricity production and even lower electricity break-even price. Let's say that we want to explore the effects of a variety of flow rates. We can do that with a Monte Carlo simulation, and we can actually press this Run Monte Carlo button, and we will see in a separate tab the Monte Carlo view with simulation program input parameters for GeoPhires that are set to our example. And then we will also see a Monte Carlo settings section. In this case, we are interested in looking at the production flow rate per well and not the defaults of gradient or reservoir, so we will remove these. And then we will go to our production flow rate per well. We see that it's the value of 90 we entered on the previous tab. And we can actually press this button to use that simulation parameter as a Monte Carlo input. And that will bring us back to our Monte Carlo settings section with the production flow rate per well input parameter. And by default, it will be a normal distribution with a mean of 90, which is the value that we had, and then a standard deviation. It has picked a standard deviation of 9 for us. And let's say we want a little bit more standard deviation. Let's go up to 15. We'll run 5 iterations for here because this is just a demo. And we will go ahead and press Run Monte Carlo Simulation. And so then again, on the right here, we get our result from the simulation, which is now running, and it has completed 1 of 5 iterations. And now it has completed 5 iterations. Once the Monte Carlo simulation is complete, we can see the statistics. The first statistics that you see are your Monte Carlo outputs, and these are just the output parameters that you have designated as being of most interest to the simulation. And in this case, the defaults of electricity break-even price, average net electricity production, and so on, these are of interest to us. So we can see we have our median break-even price of 2.44 cents per kilowatt hour, similar average, and then our range from 2.18 to 3.13. And we can see the distribution for each of these outputs. And you see them not only for your specific Monte Carlo outputs, but you can actually see every single output, the distribution as well. And for those that didn't vary, there's no bucket to show. Then, so looking at break-even price, we can see that the first bucket of 2.18 to 2.42 cents per kilowatt hour had 2 iterations that fell into that bucket. The second bucket, 2.42 to 2.66, also had 2, and then the final bucket, 2.89 to 3.13, had 1 iteration that fell into that bucket. So here we've only run 5 iterations. If we were to run more iterations, we could see a more statistically significant spread. So what I'm going to do here is I'm going to run with 1,000 iterations so that we can look at the results from a more statistically significant spread here. So this is going to start to run, and 1,000 iterations is running GeoPhires 1,000 times, which takes a couple of minutes, and we will be back once that is complete. Now we're back a couple of minutes later. All 1,000 iterations of our Monte Carlo simulation have completed, and we can see the curves a bit better of our outputs. We can see, for example, we've got what looks like a bell curve for our average net electricity production. Looks like we've got a power law going on with our average production temperature, normal distributions for some of the other outputs. But let's look at using the Monte Carlo simulation to explore optimizing a output that we're interested in. And of course, electricity break-even price is going to be one that most projects are interested in minimizing for profitability and economics. And so we might want to look at our lowest bucket here of 2.07 to 2.20 cents per kilowatt hour. We can see that 173 of our iterations fell into this bucket, and we might want to ask what were the Monte Carlo input parameters for those iterations. We can answer that by clicking the bucket, and we will actually see a sample of the individual iterations that yielded the outputs that were in this bucket. So here's one iteration, had a production flow rate per well of 119.64. You might recall that we chose a normal distribution of 90 with a standard deviation of 15, so this would be on the upper end of that normal distribution. and it gave us an electricity break-even price of 2.11 cents per kilowatt hour. And then we have another iteration that had 108.23. Again, that is getting on the upper end of your normal distribution, and a break-even price of 2.17, and so on. And we start to get the clear picture that our higher production flow rates per well are going to give us a lower electricity break-even price. So we can actually go and take those individual iterations, for example, and actually save them as new GeoPhires results. And the way to do that, we can go back to our GeoPhires tab and actually paste in the input from that iteration, run GeoPhires, and then we can explore that result in full detail. We can also save it. So we might say that this is our SHR example plus high flow rate from MC. Great. And yeah, so you can iteratively run Monte Carlo simulations, manually edit your GeoPhires parameters, and the goal is, of course, to help you model your project or your exploration in the most optimal way. And we are always trying to improve GeoPhires and improve SWS Geothermal platform to serve your needs in this area. So we hope that you found this useful, and we'd love to hear from you what features you'd be interested in seeing. Any feedback from you or thoughts are always welcome. Thanks very much for watching, and have a great day.